All right, everybody. Here is the chapter 12 and 13 review, and I'm going to break this down into individual pages. So this is page 1. All right, make sure you got your calculator ready, because without it, you are toast. All right, so here's first one. What is the molarity of 55 grams of C12H22O11 in 3 liters? And you should recognize this as your old friend table sugar. It has a molar mass of 342 grams. 12 carbons, they're each 12, that's 144. 22 hydrogens, they're each 1. And 11 oxygens, they're each 16, that's 176. Plus 144 plus 22 is 342. So the first thing we need to do is find out how many moles of this stuff do we have. How many moles of C12H22O11 do we have if we have 55 grams? Sorry. 55 grams. My pen is being a jerk. And we know that 1 mole is 342 grams. This is 0.16 moles. And we're trying to find the molarity. And molarity is, hopefully you will remember, molarity is equal to moles over liters. So if we have 0.16 moles and our volume 3 liters, what is our molarity? 0.16 divided by 3 is 0.053 molar. Okay. Let's take a look at number 2. How many moles of sodium hydroxide are contained in 65 mils of a 2.2 molar solution? Well, we remember our, that's not what I wanted. Sorry, I bumped the wrong page for a second. We know our triangle. That looks like this. And we know that molarity is equal to moles times liters. So let's flip this equation around to find moles. We know that moles is equal to molarity times liters, right, according to our triangle. And we know 65 mils in a 2.2 molar solution. So we know the molarity, 2.2 molar. 65 mils, by now you should know how to convert from milliliters to liters simply by dividing by 1,000. So we're going to say times 0.065 liters. So we have 2.2 times 0.065 is 0.143 moles of sodium hydroxide. All right. Here is number 3. It says determine the number of grams of solute needed to make each of the following molal solutions. Okay. So since it's specifically asking for grams, that means we're going to need to start with moles. And we know that this triangle works for molality too, where molality is equal to moles over kilograms. So if we're trying to find grams of solute, we should look for moles of solute first. So let's do this. We're going to say moles is equal to molality times kilograms. And we have 4.5 molal right here. 1 kilogram, so that's pretty easy. That's 4.5 moles. Now, if it's asking how many grams of our solute, which is clearly sulfuric acid. Okay, so what mass, how many grams of sulfuric acid, H2SO4, do we have if we have 4.5 moles of H2SO4? And we should know that the molar mass of sulfuric acid is 98 grams. Sulfur is 32. 4 oxygens, they're each 16. That's 64. Plus 2 hydrogens in 1 mole. So, how many grams do you have if you got 4.5 moles and there's 98 grams in a mole? 441 grams. All right, do the same thing for this one. It's a 1 molal solution, so we're going to say moles is equal to molality times kilograms. We know we have a 1 molal solution and 2 kilograms, so that's pretty easy. You don't even need a calculator for that one. Is 2 moles. In this case, it's HNO3. Well, how many grams of HNO3 do you have if you have 2 moles of HNO3? Pretty straightforward, because we know that 1 mole of HNO3 is 63 grams. You've got 3 oxygens, they're each 16. You got a nitrogen, that's 14. We're up to 48 plus 14 is 62, plus 1 hydrogen is 63 grams. So look at me, not even using the calculator. 2 times 63 is 126 grams HNO3. All right. Okay. This is number 4. And it says, using the solubility guidelines, predict whether each of the following compounds is soluble or insoluble. Okay. We can make this go really fast. Check this out. Anything that has sodium, potassium, and ammonium in it is automatically soluble. Automatically. Means it is not going to form a precipitate. Also, anything that has a nitrate, remember that nitrate is a polyatomic ion, and that looks like NO3, right? Acetates and chlorates are always soluble. So we can go right through this and we can say, okay, anything that's got potassium in it, this guy, soluble. Anything that's got a nitrate in it, that guy, soluble. Anything that's got ammonium in it, that guy, soluble. Okay. The rest of these are not quite so cut and dry, but they're pretty straightforward. So here is silver chloride. It says that chlorides are soluble unless they contain silver, mercury, and lead. Well, that's silver. So that is insoluble. Okay? Barium sulfate, it says here, most sulfates are soluble unless they contain, ding, 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 barium. That guy right there. Insoluble. This, sorry everybody. Calcium phosphate. It says most carbonates, phosphates, and silicates are insoluble, except those that contain sodium, potassium, and ammonium. So it's got a phosphate in it. It's going to be insoluble. That guy. This is called lead chlorate. This says that nitrates, acetates, and chlorates are always soluble in water. So that guy, this guy right here, he is soluble. This is lead iodide. This is the bright yellow stuff that we made right when we first started discussing this. You know, you're going to buy me a yellow Ferrari, that guy. It says iodides are soluble unless they contain silver, mercury, and lead. That guy, insoluble. This is called iron 2 sulfide. It says here that most sulfides are insoluble. Ding, 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 ding. So that guy, insoluble. Sorry. And finally, here is aluminum sulfate. And it says most sulfates are soluble except they contain barium, strontium, lead, calcium, and mercury. Well, that's aluminum. It's not lead, calcium, barium, strontium, lead, or mercury. That guy is, this one is soluble. Okay, don't get all too crazy and complicated. When we are dissolving, let's remember that these are all ionic compounds. They all split right down the middle. There's no point in doing this. Otherwise, they all split right down the middle. So, and we're not going to do anything with the polyatomic ions. Just leave them alone. So, that means lead iodide is going to dissociate into, potassium iodide is going to dissociate into potassium and iodine. Magnesium chloride is going to dissociate into magnesium and 2 chlorines. Do I care if you don't put the charges on there? No. This is sodium nitrate, and this is going to dissociate into sodium and nitrate. And finally, sodium sulfate. Be careful because sulfate, that's a polyatomic ion, but sodium isn't. So Na2SO4 is going to dissociate into 2 NAs and 1 SO4. And that's all we care about. And that's the first page.